a marathon session of waves. Like you all know, we have started with transverse waves, then sound waves, then yesterday we have done light waves or basically electromagnetic waves. Now today we are going to see some more properties of waves, and that is standing waves, beats, Doppler effect, resonance. And I hope you remember the term of resonance, and that is clearly demonstrated in this small video out here. You can see a tuning fork is struck with a hammer and that produces sound waves. Those sound waves are incident on another tuning fork of the same frequency, hence it resonates, and the fact that it resonates also you can see that by the motion of the pendulum or the motion of that ball, because the tuning fork starts vibrating. You can see the ball also begins to vibrate because it is having a large amplitude. So that's resonance, in case you have forgotten. We are also going to end our lecture with Doppler effect, and I'm pretty sure many of you have the problem of sign convention and you do not know when to use plus minus, and you do not know what to do when there is a reflecting surface, or what if there is wind blowing and then you are asked to find the apparent frequency. We're going to study all of that along with what is beats. So get ready with me, Shreyas, your master teacher for physics at Vedantu, going live from Bangalore. Hello Priyanka, hello Yalini, hello Aishwarya, hello Minion Aarti, hello everyone, hello Science Priya, welcome Dia, good evening everyone, good evening all the minions out here. Yes, let's begin our class. And those of you who are new to this session, do not forget, the only way you can mark your attendance and you can show that you are here and other people also get to know you is when you chat in the chat box. So do not hesitate to post your comments as well as interact with other students out here, and also give a brief introduction about yourself to everyone out here. Welcome aboard. Hello Sashi, hello, hi. Nice name. Okay, welcome everyone. So those of you who do not know me, I'm Shreyas and I'm the physics master teacher, and I've been teaching for quite some time, and not only in Vedantu but also in offline institutes, and many of my students are in IITs, NITs and other top institutes, and many of them have even got really great ranks. In fact, I have produced top 100 All India ranks in the JEE examination in the past few years of my teaching. Also, you can know more about me and my daily life on Instagram. That's my Instagram handle, Shreyas_Vedantu. Do check it out whenever you are free. And before we begin the session, do not forget to hit the subscribe button if you are new to this channel. It's free of cost, and do not forget to smash that like button out there in case you have forgotten to do so, because remember, this is free. So you need to show us your love and support so that we can conduct more such sessions like this. And thank you for all the people who keep posting all the lovely comments and all the appreciation that we receive, and all your suggestions, feedback, everything. We duly consider everything, whatever you post in the comments, and we make sure that we provide you the best kind of content, the best kind of questions and the best explanation out here in English. This is an English medium channel because there are hardly any English medium channels out there on YouTube. So do not forget to hit the subscribe button as well. Now in this week, like you can see, mainly we are covering waves, be it 11th standard or 12th standard portion. Like you can see, this and this are 11th standard portions, L1 and L3. L2 is a 12th standard portion. L4, tomorrow, Young's double slit experiment diffraction will be covered. And then we are going to start with modern physics. We have a lot of sessions lined up for you so that you are very well prepared before you enter the next probably cycle of your academic year, or probably before your exams end and stuff like that. So modern physics starting up next week. Please keep in mind, some of the lectures are at 10 o'clock and a special session on Sunday, Valentine Day special. Now there is another important announcement that I would love to make. Keep this in mind. Well, there is a very special thing coming up for all those students out there who want to prepare for JEE Advanced. Hello Alshad, hello Deepak, welcome aboard. Yes, so it's not a mentee, it's a marathon session, Alshad. So it's going to be a big session, but it's a one-shot session where we'll talk about Doppler effect, beats, standing waves, everything, both transverse and longitudinal. So I know many of you are probably confident that yes, you're going to nail the mains examination, or you know that once the mains is over, you're going to begin your advanced preparation. So there is something really special coming up for all of you by our very own Anand Prakash sir or AP sir. So stay tuned to get to know more details about this. All right. So that was a brief information I would love to tell you about. Now let's begin. Let's begin. Hi Manoj. Good evening, guys. Good evening. Let's begin our class, guys. Now everybody recollects what was waves. Waves was nothing but flow of energy from one point to other without the particles themselves having to move. So like the waves on ocean or the ripples of water, they transport energy from one place to other, but the particles as such maintain their average position, or their average displacement is zero. That's what waves was. Now you might be wondering what exactly is standing waves. Now do not think standing wave means the wave will not move. No, the wave will move, but the energy will not flow. Meaning, imagine you have two waves. Look at the green one and look at the blue one. Two waves of same energy, same wavelength, etc., moving in opposite directions. The green wave will carry the energy from left to right. The blue wave will carry the energy from right to left. In total effect, or the resultant motion will be such that the energy will neither end up going from left to right or from right to left. The energy will be trapped and the energy will be confined in some region. So that is basically called as standing wave, because the energy is trapped, it has nowhere to go. Alright, so there is no net flow of energy. That is the meaning of standing wave. Correct. So if two waves of same frequency and amplitude moving in opposite direction, then the resultant is called as a standing wave. That's the definition. I hope you keep writing down all these things because these are very important stuff. And some more points that I can give you over here. As I write, you can also write it down. This is basically trapped energy. And because that energy is trapped, you can say it is confined. Okay, so it's confined in a region, you can say. And we'll see what that region is in a bit. Don't worry about it. And this is how the waves will be. They will be going in opposite direction. The resultant motion, how will it look like? We'll just come to it. Okay, so the resultant motion is called as a standing wave. Keep this in mind. Okay. Now, what is the equation of a standing wave? Well, we have seen equation of a wave before this. So let's say you have a sine wave traveling from one side to the other, like this one. So the equation of that wave will be A sine, because it is going towards the right side, so it will be kx minus omega t. Whereas a wave coming towards the left side, that will have an equation A sine kx plus omega t. Now, if I add both of them, what I will get? Y is equal to y1 plus y2. If I add both of them, I can use sine C plus sine D formula and I can see what is the resultant wave equation. So sine C plus sine D is 2 times of, alright, sine of C plus D by 2. Now C plus D, kx minus omega t plus kx plus omega t. It will be kx plus kx by 2 into cos C minus D, or D minus C, one and the same thing, guys. So anyways, so minus omega t, and you will again have minus omega t divided by 2. Now you can do something further. This will become 2a sine. 2 by 2 is 1, so it will become just sine kx, and here it will become just minus omega t, but do not forget cos of minus theta. Alright, cos of minus theta is cos theta. That's the formula I will use, and that's why I will just get over here as cos of omega t. So that is the resultant motion. That is the resultant motion that I got. If I assume them to be sine waves, do I have to assume them to be sine waves? No. What if it is something else? Don't worry, just add them. If it was cos and cos, then you know cos C plus cos D formula. Use that, you'll get the answer. So depending on what you choose initially, this final terms may contain sine or cos or different terms depending on what you chose initially. But the idea is you will get something sine or cos kx into sine or cos omega t. That's the whole point. Hello Ankit, hello Manjunath, hello Charishma, hi Princey, good evening. Hello everyone. Alright, so the whole idea is you will get something into sine or cos k into x dot or multiplication cos of omega t. That's the whole idea. Now you might find it difficult to analyze this equation at first. Do not worry, I'll tell you how to analyze this equation. So let's see how will this equation exactly look like. For now, I hope this is clear. Now when you look at this equation, guys, okay, I'll just write it for you. Y is equal to 2a sine kx into cos omega t. Now what I'm going to do is just look at this term, this complete term over here, and look at this term separately. Now if you treat this term as one number, treat it as a number. It could be 5, it could be 10, anything. Just keep a number in your mind. For example, let's say 10. This will look like y is equal to 10 cos omega t. Does it remind you of something? Yes, it should remind you of SHM. Y is something cos omega t. It's a SHM. Correcto. So that means that particle is going to go up and down with angular frequency omega. Alright, and the amplitude will be this number. So this number over here is going to be nothing but the amplitude. Alright, and this thing over here is the oscillating term, and this oscillation is obviously dependent on time. It's a function of time, you can see that. But there is a catch. What is the catch? This number, which is the amplitude, is not a constant. Why? Because there is x over here. So in fact, it is a function of x. That means for different values of x, the amplitude will be also different. So we are trying to analyze the wave equation, the standing wave equation, by adding two waves moving in opposite direction. This is the resultant we got, and we saw that the resultant equation is some number into an oscillating term. That number is a function of x, and that number I have called it as the amplitude. So different points have different amplitude. I hope that's clear. Hello Yavar, welcome. Now what you should understand is, obviously the value of sine will be 0 sometime. Like for x is equal to 0, or whenever whatever is there inside becomes 0 or pi or 2 pi or 3 pi. So there are some points with 0 amplitude. Do you agree? Also there will be some points with very large amplitude when this sine term will become 1, like for 90 degrees or 270 degrees and so on and so forth. So for all these numbers, you can see that, you know, when sine value is maximum, like either 1 or -1, this number will be very large. So those amplitudes will be very large. I hope that makes sense. So what are you going to see? You are going to see different particles. Let's say a particle 1 with 0 amplitude, another particle with small amplitude, another particle with large amplitude, another particle with even large amplitude, another particle with not so large amplitude, and the amplitude will keep changing and changing. Again you get 0, and again you will get a particle with some amplitude like this. So these are basically the motion of different particles, all right, at different instants of time. So the particles are going to go up and down, and the string is going to also go up and down. How will it look like? I'm just going to erase it in order to play the simulation. So keep this in mind. Amplitude as a function of x into oscillation as a function of time. So let's see how does it exactly look like. Okay, I'm not sure why it's not playing, but it's okay. I will show that to you on a separate graph out here. So guys, I'm just going to write a equation. So pay attention. What is the equation I'm going to write? Y is equal to, let's say, 2 sine, okay, maybe let's say, I don't know, 3x maybe, 3x, this is how it is. If you write let's say 1.5x, it will look something like this. Okay, so this is our graph, guys. This is what we are looking at. Now I'll just put another term over here like cos, and maybe, hello Shabana, join in. Let's say cos 3t. That's what we'll see. And let's add a slider out here. And let's say the slider value will go from, or maybe I'll put 3 pi over here, maybe. That's okay. And yeah, it goes from, maybe, hold on. Just my t kuch dal dete hain. And 0 to maybe 2 in the increments of 0.01. Okay, now let's see how does it work. Let's play this and see how it works. Look at that. That's a standing wave, guys. Do you see there are some particles with no amplitude, 0 amplitude, and some particles with maximum amplitude? So when two waves go in opposite direction, their resultant motion is exactly this. Yes, this is the resultant motion of that. I hope that is clear. This is a standing wave. Now where is the energy trapped, you might say? Well, the energy is trapped here, and here, and here, and here, and here. So the energy is trapped between these 2 points. That's it. The energy cannot go outside of them or inside of them. Again, some amount of energy is trapped here. It cannot go outside of this or inside of this. Some energy is trapped here. It cannot go outside nor inside. So you can see trapped regions of energy. Amazing. All right. So that's how it works when you have two waves going in the opposite direction. That's how a standing wave looks like. Okay. So that was the formation of standing waves, guys. Now, what are those regions called? Well, the nodes are nothing but those points with 0 amplitude. Keep this in mind. Nodes. What are nodes? Nodes are those points with 0 amplitude. Keep this in mind. 0 amplitude. Similarly, what are antinodes? Antinodes are those points which have maximum amplitude. With maximum amplitude. And what was that amplitude? Recollect, it was 2A. Okay, it was 2A. Now, there is one more term which you should know. That is this particular region. This particular region or this region, that is called as a lobe. What is it called? As a lobe. And that's where the energy is trapped. So each lobe has some trapped form of energy. And here also there is some energy trapped, here also, here also, here also. And nodes are those points which act like walls or barriers for the energy not to flow. Okay. And last thing which you should know over here, check this out. Over here like this. I hope you can see this. Okay. See this. This is one wavelength. That also means the length of a lobe. If this is one wavelength, guys, what is the length of a lobe? The length of a lobe is lambda by 2. Keep this in mind. So if this is one wavelength, the length of a lobe is lambda by 2. Very good, Ankit. Keep making notes. No, Yavar, it's not all the points where amplitude is not 0. Only those points which has maximum amplitude. Alright. So only those points are called as antinodes, Yavar. Alright. Yes. Cool. Let's get going. Very good. Alright, Princey has stethoscope always in her head. So whenever she puts a smiley, there is a stethoscope out there. Alright. So basically, yes, Bhaskar, this is an English channel. So Ankit, those points like you saw in the simulation where it has 0 amplitude, they are nodes. Those points which have maximum amplitude, antinodes. Other points don't have maximum amplitude. And last thing, the region from one node to other node is called as a lobe. That's the region where the energy is trapped. And since this is one wavelength, you can see a wavelength over here. So that's why one lobe is wavelength by 2, half of the wavelength. Keep this in mind. Alright, cool. Now, there are some more important things that I would like to tell you guys. So I'll just erase this. Now these are some very important pointers you must know. In a lobe, if you see, all the particles will go up together, all the particles will come down together. All particles will go up, come down. So, particles in a lobe are in phase. Very, very important. Are in phase means the phase difference between them is 0. But if you look at the particles here in this lobe and the particles here in this lobe, you will see if these particles are going up, then these particles are actually coming down. So the particles in adjacent lobes are exactly going to do opposite things. If this goes down, that goes up. If this goes down, that goes up. So they are doing opposite things. So I can say particles in adjacent lobes are out of phase. That means the phase difference between them is pi radians. Keep this in mind. Keep this in mind. Yes. Very good. Very good. Very good. Now, next up, very, very important is, keep this in mind, each particle has different amplitude. Each particle in a lobe, or I can say in general, each particle has different amplitude. But one thing is same, all particles have same frequency. Now why are these pointers important? Because when you have a normal traveling wave, keep this in mind, each particle has same amplitude. Yes, they might come up at different times, but in a normal wave, all the particles have same amplitude. I hope this is clear, but in standing wave, that is not the case. The only point which is similar is all the particles will go up and down at the same time, so they have the same frequency. That's the only point common. And about these 2 pointers out here, remember, for particles in a lobe, the phase difference is 0. But in a normal wave, I hope you remember, between any 2 points which are separated, there is some phase difference which is given by 2 pi by lambda into delta x. I have told you about this. Every point has a phase difference with the next point. But that's not the scenario in a standing wave. They all go up and down together. I hope these points are clear. So these kind of differentiations are also asked sometimes as theory pointers in the examination. Hello Pramesh, join in, welcome. Pramesh, whatever comments you put, I'm not able to reply on them. I'm not sure why. Just check your settings if you're blocked or something like that. So whatever comments you put, I'm not able to reply. Just check on that. All right. Yes, let's begin. Next coming up on your screen. So 2 waves which are traveling in opposite directions, they produce a standing wave. The wave equations are given. Notice this, it is in centimeters, where x and y are in centimeters. Find the maximum displacement of the particle at x equals to 1.57 and find the smallest distance between the nodes or the antinodes. Let's do it part by part. Okay, let's start with first A. Now, if you notice, when I add these 2 equations, the resultant, alright, the resultant equation will be 4 will become 2 into 4, which is 8. 2a, remember what's 2a? 2a, and you will have sine of kx. K over here is 3x into cos 2t. That is the final equation I'm going to get. Out of that, this much part is nothing but your amplitude. Keep this in mind. This is the amplitude. Now what have they asked? What is the maximum displacement? What is the meaning of the word maximum displacement? Nothing but amplitude. What are they asking is, what is the amplitude? So amplitude at x equals to 1.57. So amplitude at x equals to 1.57 will be this one over here, 8 multiplied by sine of 3x. But instead of x, what will you put? 1.57. I hope this is clear. That is what they are asking. Yes, I hope this is clear. Cool. Now, one thing. Oh my God. The moderator, please, I think you have put up a wrong channel name out there. It's not Vedantu Young Wonders. That's a separate channel. Though you can definitely like and subscribe. That's for the younger grades 6 to 8 standard if I'm not wrong. Yes, let's get going. Okay, so very interesting thing to note here is 1.57. It's a special value, guys. What is 1.57? It is 3.14 divided by 2. Yes, it is 3.14 divided by 2. So it will be nothing but 3 times pi by 2, approximately pi by 2. So what is sine of 3 pi by 2? It is 1, because it is magnitude wise it is 1, actual value is -1. Remember, whenever we talk about amplitude, you should always worry about the modulus, even if it is negative. Yes, even if it is negative, keep this in mind. So although the answer might come out to be 8 multiplied by -1, please understand the final answer will be 8 centimeters only. Okay, keep this in mind. So it is always the modulus of that. Yes. Cool. Okay, great. So Ankit, it is just nothing but 2 waves going in opposite directions. That's what they have given. Remember, we just did this and they have asked find the resultant waves amplitude at this distance. So we know what is the resultant. I just did this some time back, and you remember this part was the amplitude I just showed. So I've just substituted the value of x as 1.57 in order to get the amplitude. That's all I've done. Cool? Okay. Now this is only the first part. Now let's go to the second part. Now for the second part, here is what we'll do. Okay, I don't think I'll need this also. Now find the smallest distance between the nodes or the antinodes. So guys, if this is how the standing wave is going to look like eventually, all right, these are the standing waves. Okay, it looks something like this. So if there is a node here and another node here, what is the distance between them? The distance between them is lambda by 2. So that is what they are asking, the smallest distance between node to node or antinode to antinode, one and the same thing. So they are asking you what is lambda by 2. Now for doing that, check over here. From this you will easily understand the value of k is 3, and remember k is actually 2 pi by lambda. Recollect from the previous lecture, k is 2 pi by lambda, angular wave number, that is equal to 3. That's it, guys. So think about it. What is lambda? Lambda is 2 pi by 3. So the required distance, which is lambda by 2, will be nothing but pi by 3 centimeters. That is the answer. Yes. Okay. I hope this is clear. Okay. Let's get going. Cool. Let's get going. All right. Yes, 8 centimeters and pi by 3 centimeters. Next question coming up on your screen, and here it is. Think about it. Yes, so a standing wave is formed by the superposition of 2 waves traveling in opposite directions. The transverse displacement is given by this value is equal to 0.5 sine 5 pi by 4x cos 200 pi t. So this is the resultant wave equation. So standing waves equation is given to you, which is the result of 2 waves going in the opposite direction. Okay. Now, what is the speed of the traveling wave moving in the positive x direction? What is the speed of the traveling wave moving in the positive x direction, which makes up one of that 2 waves? Think about it. Come on, think about it, guys. What will be the answer? Come on, guys, think. Think about this. Okay. Cool. A, B, C, D. All right, let's see what the correct answer should be. Well, in this particular question, the transverse displacement is given to be, this equation. Now from that, I can easily identify k is 5 pi by 4. Okay, K is 5 pi by 4, and omega, which is over here, is 200 pi. Now, do you remember that the wave speed is given by omega by k? So if it is omega by k, so it will become 200 pi. Remember, 200 pi divided by, what is this? 5 pi by 4. So guys, this 5, this will become 40. All right, pi and pi goes. So it will become 160 meters per second. That should be the answer. The velocity is omega by k. Don't worry about such a big question. Wave questions are simple. Just identify omega and k, and that is the wave speed. That's it. Very good. Very good. Correct. Probably over here. Okay. I think the wave question is slightly different. Just going back to the previous question. Look over here. It's not kx minus omega t. It is omega t minus kx. So we need to be a little bit careful. Yes, so we need to be a little bit careful. I think the standing wave equation is going to be y is equal to 2a, and here you will have sine of omega t and cos of kx. Please keep in mind, if it was kx minus omega t, then you would have sine kx cos omega t. But here it is sine omega t minus kx. So I believe it should be 2a sine omega t, alright, and cos kx. Yes, yes, that's the change. Be careful, be careful. So if that is true, think about it. This much part is not our amplitude. I'm going to have, okay, I need to rearrange it. I just need to get that x term. Okay, so this will be 2a cos of kx into sine of omega t, because whatever is there in x, that is going to be my amplitude. So this is actually my amplitude. Think about it. This is my amplitude, and this is nothing but my oscillation as a function of time. Now they have asked, you know, the resultant is going to be what? The resultant is going to be a standing wave. The resultant is going to be a standing wave, but where will the node be? Where would the node be? Well, here is the thing. So at the node, think about it, the amplitude must be 0. Therefore, what will I get? This cos kx must be 0. Therefore, I should have kx is equal to, now kx will be either pi by 2 or 3 pi by 2, or basically any odd number pi by 2. Now you can do it further. K is nothing but 2 pi by lambda. K is 2 pi by lambda into x is equal to odd times pi by 2, and therefore pi will go. All right. So you will have x is equal to odd times lambda by 4. 2 into 2 is 4. So odd times lambda by 4, that is what you will get. Yes. Hi, Mr. Best. Yes. Yes. Here the class starts every day at 7 o'clock. So if that is the case, odd number can be written down as 2n plus 1. Any odd number can be written down as 2n plus 1. So now you can check what the option should be. Yes. So if you write 2n plus 1, if you take LCM, 2n plus 1 by 2, 2 into 2 is 4. So at all these points you will have nodes. So option D will be correct. Yes. Yes. I hope this makes sense now. Okay. Thank you, Sashi. Yes. So we need to look carefully at omega t minus kx or kx minus omega t. Be careful. So this was an eye-opener problem. Okay, cool. Let's get going. Now, there is a very special news. Today is a very special day. I'll tell you what. For all the students who want to get their doubts solved and who want test series and who want to cover the entire syllabus in a very small time, because there are hardly few days left for, you know, the upcoming first attempt and then the next attempt of JEE Mains. So we have come up with a very special plan, and most of you already know about it, but still guys, remember, you need some assistance. So feel free to take that assistance, be it for doubts, be it for learning, be it for probably counseling, be it for mentorship, and you need someone to guide your way through in the last few days. Because if you make a mistake, then there is no way you can correct it, because you do not have time the time is the most crucial thing in the last few days before you write your JEE examination. So the plan that we have for you is, regular classes where all the live classes, in fact, all the portions of 11th and 12th will be completed, along with inside the class and outside the class doubt solving from morning till night, with test series and their discussions, revision notes, handwritten notes, and also special assignments. Along with this, you also understand doubt solving right from morning till night. That's very, very important. And the best part, like I was telling you, usual price is 10,000. Usual discount is 20%. But today the discount is 30%. Yes, the discount is 30%. Like many of you probably know that these special offers run only for a few days, limited time. Usual discount 20%, now the discount is 30%. So you get it for 7,000 rupees. 45 classes, test series, doubt solving, right till the last exam. What more you want, plus handwritten notes, everything. All the details are mentioned below in the description box. Check it out, read it, and join today because the batch has already started. But don't worry, you can also join the next batch. Enroll yourself right away so that you do not miss this chance. Use the coupon code SHCC to avail this offer. Yes, use this to avail this offer. Thank you, Mr. Best. I'm really glad, guys. And please keep in mind, I'm going to be always there for you over here, because see, these crash courses are obviously there for you guys to definitely boost up your score, for personal attention, for personal mentorship and all those things, and live discussions of tests. But remember, whatever we do on this channel will always remain for free, and it will only come through your love and your support. Hi Jagannath, welcome, join in. Yes. So do not forget to keep liking our videos, keep subscribing to our videos in case you have not done it yet. Now let's move on to the next part. Before moving to the next part, my throat is a little bit itchy, I'm a little bit hungry. So break time, guys. Any idea what I have today for snacks? Okay, let's see how many of you can guess. Join in all the new students. Hi Raj. Any guesses? Water? No, today is not water. And finally, it's some sugary thing. And I'm pretty sure it's your favorite too. No, it's not a sandwich. It's everybody's favorite, I'm sure. Valentine's Day special is a lecture. Gulab Jamun? No. Chocolate? Close by. How many of you? Okay, chal, I'll give you a hint. It's a 4-letter word. It's a 4-letter word. No, it's not rasgulla. It's not a cake. No, it's not sweethearts or little hearts. Wow, Minion Aarti has got chocolates, gone mad. No, it's not 4-letter. And here it is. What is this? Anybody knows what is this? No, it's not a grape. Oops, grapes has more letters. Yeah, Oreo. No, it's not milk. Can you hear that crunching sound? Too good. Oh, Aishwarya got cookies. Wow. Here it's not oral. Oreo. Very nice biscuits. And you get those Oreo shakes and Oreo based pastries. It's so cool. Yes, Manjunath, that's the whole idea, whole intention. Hey, I love waffles. Too good. Have those Belgian waffles. It's very nice. I love waffles too. We were thinking of getting a waffle maker, but then I realized that if you have a waffle maker at home, then probably every night we will have waffles, so we skipped the idea. Ankit, which muffins you like? Or any muffins? Koi bhi muffins chalega. Wow, samosa, yalning, very good. Have it with nice chutneys, nice chatpata sauce. Yes, Manjunath, a small break because this is a marathon session. Okay, let me drink some water. Yavar, please don't say such things. Please don't say such things. I'm scared. And I promise I'll brush my teeth before sleeping. Chalo. Let's begin. And guys, yeah, I think there is a separate Telegram group where all the minions are there, so you guys can also join in the Telegram group, and that too, you should prove your worth to be in part of that group. Yes, let's begin. Okay, now let's talk about standing waves, how to create them. Now, there are two places. One is on strings, second is in pipes. Now, standing wave on a string is produced in a guitar, sitar, piano, all these things. They are string instruments where you create a wave, that wave goes, reflects, comes back, and because there is a wave going this side and there is a reflected wave coming this way, so you will have two waves going in opposite direction, that produces standing wave. Similarly, examples of organ pipes will be trumpet, flute, alright, all these examples, or the mouth organ and all that. So all these are examples of organ pipes, where again you create some sound, that sound gets reflected and comes back, and then you have two waves going in opposite direction, that creates your standing wave again. Yes, so that's what we are going to see now. Okay, and that's what we're going to see now. Now there are three cases in this. Yes, there are three cases in this. What are those three cases? See, either the string is fixed at both ends, that is very similar to a pipe closed at both ends. Then next is string is free at one end, fixed at one end, which is similar to a pipe open at one end and fixed or closed at one end. And the last one, string is free at both ends, which is similar to a pipe which is open at both ends. I hope this is fine. Now, when you have a pipe or a string, all right, in this fashion, understand wherever the end is fixed or wherever it is closed, that's where you get a node. What will you get? You will get a node wherever the end is fixed or it is closed. Why? It's very easy to understand. This point is fixed point and it cannot move up and down. So if there are waves coming here and the wave is getting reflected back, understand this point is constrained not to move. So what will that point be? It will be a node. So similarly, if this end was free, then that point will move up and down by a large amount, and that would be an antinode. Keep this in mind. Now we are discussing the first case. So wherever the ends are fixed, this is a fixed kind of a rod, string. So you will have a node here and a node here, and you will also have a node here, and you will also have a node here. Now think about it. If I tell you, you need to create a standing wave with two nodes here, what are the different possibilities? Well, you will whack your brains a little bit, and scratching those brains, you will realize that yes, one possibility is you have a standing wave like this with only one lobe. Obviously, that's one possibility. I hope that makes sense. Then I tell you, is that the only possibility? Then you will think again, well, no, actually, you can have more possibilities like this one. You can have two lobes like this. Well, this is also a node, this is also a node, this is also a possibility. Is this the only one? No, there are more. In fact, you can have like this, you can have three lobes, and then you can have even more lobes like this. So 1, 2, 3, 4, like this. So this is also a possibility. All these are the different possibilities that you can get when you have two nodes, node here and node here. I hope that is making sense. Now, this is what I have shown. The first possibility, this is the smallest possibility that you can have. All right, you have only one lobe here, then two lobes, then three lobes, and so on and so forth. That is the possibility that you can get. So, do you agree for a particular length, for a particular medium, there are only certain fixed wavelengths which can be accumulated over here, which can fit inside this tube or this string. I hope that makes sense. Not all wavelengths will fit in. Only certain wavelengths can fit inside this tube or on this string. If certain wavelengths only can fit in, that means only certain frequencies can fit in, and that formula is, well, here it comes. The formula is F is equal to NV by 2L. And you can also derive this using this simple logic. Whatever is the length, all right, that length is n times of lambda by 2. Why is it lambda by 2? Because the length of each lobe, is exactly lambda by 2. So n times of lambda by 2 is the total length of it. And just rearranging it further, that lambda is V by F and all, you will get this answer. So keep this in mind. This is very important formula. N is any integral value, positive integral value. I hope this is clear. Yes, N is some positive integral value. If it's a string, then the value of velocity will be root of t by mu. Whereas if it is an pipe, then the value of V depends on whether it is a liquid or a gas. So if it is a liquid, you will use B by rho, and if it is a gas, then you will use gamma P by rho, right? So that's the formula that you will use. I hope this is making sense. Alright, Ketki, suddenly you are saying Oreo. I'm guessing that you are watching the video in a replay manner or something. Alright, okay. Yes, Nick, don't worry. You will, I'm pretty sure after watching these videos, at least you'll get some confidence on waves, because waves is theory wise very intensive, but problems wise it is very simple. Okay, cool. Let's get going. Now, coming to the next part out here, string fixed at one end and free at the other. Like I was saying, guys, the one end which is free will have antinode, and this part will have node. So this will be node, and here will be antinode. So a pipe which is opened at one end. So what are the different possibilities that you can have? One possibility is you just have half the lobe over here. You can say that half the lobe, node here, antinode there. That's not the only one. You can have more, guys. Think about it, probably like this. So you can see 1.5 lobe over here. All right. Then you can have another possibility like this maybe. All right. Something like this. So node here, antinode there. So you can see numerous possibilities are there. And this time the frequency is odd multiple of V by 4L. Be careful. It is 4L. Earlier it was 2L. Here it is 4L. Keep this in mind. Yes. Oh my God. Looks like Ketki is, yeah, definitely lagging behind. She is watching the replay. Okay, cool. So this is the formula. Now, a lot of books write it as 2n minus 1 or 2n plus 1. Guys, that is very confusing. Do not use that. Believe me, I tell you by experience, do not put even n plus half and all that. Always put odd. Just put odd. You will be able to solve the problem. You don't have to think anything. Believe me, just put odd number. That's it. That's it. Just put odd number. That's the formula. Okay. Then the last one is when the string is free at both ends. If it is free at both ends, then you have antinode here as well as antinode here. So you have antinodes at both the places. Antinode over here. And this is a pipe, by the way. This is an antinode over here. So the different possibilities that you can get are, one is like this. Antinode here. That's one possibility. Then another possibility is probably something like this maybe. This is another possibility that you can have. All right. And another possibility can be maybe something like this. Yes. Yeah. So these are the different possibilities that you can get. And in this situation, that frequency is NV by 2L. Same like the original formula for fixed ends. Very similar. So free formula is same as fixed formula. Keep this in mind. Strings free at both ends, formula wise is same as string fixed at both ends. And only when the string is fixed at one end or the pipe is closed at one end, instead of n you will have odd number, and instead of 2 you will have 4. Keep this in mind. Yes. Okay, cool. Yes, keep this in mind. Now let's come to the difficult part. Now a lot of people do not know this, and a lot of people are not told this in the class. That's why I'm going to give you some time to understand this. See, how is the naming done? Now I hope you see that there are certain frequencies only which are permitted on that string or in that pipe to produce standing wave. Example, let's say the first frequency in some string is 100 Hertz. Example. Let's say the next frequency, I'll write it here. Let's say the first frequency is 100 Hertz. Let's say the next frequency is 200 Hertz. Let's say the next frequency is 250 Hertz. Let's say the next frequency is 300 Hertz. Let's say the next frequency is 500 Hertz. And let's say the next frequency is 520 Hertz. Example. These are the frequencies. Now, listen to me very carefully, because or else you will get confused. The smallest frequency permitted is called as the fundamental. Which is the smallest? This one. So the smallest one is always the fundamental. So this is called as the fundamental frequency. Keep this in mind. This is the fundamental frequency. Okay, this is the fundamental frequency. Now, the fundamental frequency is also called, yes, it is also called as the first harmonic. What is it called? The first harmonic. Now, if this much is clear, okay, now very important, hold on, let me just draw lines over here so that there is no confusion. Okay. Now, keep this in mind. This 200 is how many times of the fundamental? This 200 is how many times of the fundamental? Ankit, the smallest frequency is called as fundamental. That's all. These are the frequencies of something. Doesn't matter what is it. I'm just teaching you how to number it. Just pay attention. Okay. How many times is 200 of 100? Come on, guys. Think about it. Twice. So this is called as the second harmonic. Now harmonic in general means how many times, all right, of the fundamental. How many times of the fundamental? How about 250? It is 2.5 times. So it is 2.5th harmonic, I can say. It is the 2.5th harmonic. How about 300? It is the third harmonic. But generally, this 0.5 harmonics are not written because they are off the tones, right? So usually you have integral number of harmonics. So think of it this way. This is first harmonic, second harmonic, third harmonic. Generally you will not get these times, but just for the sake of it, this is the 2.5th harmonic. Okay, this is the third harmonic, this is the fifth harmonic. All right, and this one is 5.2th harmonic. I hope this is clear how the harmonic works. I hope this is clear. This is how the harmonic works. Now, talking about overtones. Overtone means 200 Hertz is how many frequencies above 100? It's the first frequency that you get above this fundamental. So that is why this is called as the first overtone. This is the first time you get any frequency over the fundamental frequency. This one is the second frequency you get after the fundamental. So that is why it is called as the second overtone. This is called third overtone, and this is called a fourth overtone, and this is called as, you know, the fifth overtone. I hope this is clear. I hope this is clear. This is how the numbering is done. This is how the numbering is done. This is something which many people did not get it, I'm pretty sure, before this, but now I hope this is clear. Okay, so guys, going back to the previous slides, think about it. If I tell you the pipe which is fixed at both ends, or string which is fixed at both ends, if this is the first harmonic, which overtone is first harmonic? It's not any overtone, it is just fundamental. It is just the fundamental. But the second harmonic is the first frequency over the fundamental, so it is the first overtone. And this one is nothing but the second overtone. I hope this makes sense now. Okay, but remember one thing, that when the string is fixed at one end, now you need to be little bit careful, because if this is fundamental, all right, if this is fundamental, this is first overtone, this is second overtone, but after fundamental or the first harmonic, you do not get the second harmonic, you get the third harmonic, because remember guys, frequency was odd times V by 4L. If frequency was odd times V by 4L, that means the first frequency will be the first odd number into V by 4L. The next frequency will be 3 times V by 4L. The next frequency will be 5 times V by 4L. Do you see only odd harmonics are present? I'm very good, Hemang. I'm very good. Join in. Yes. I hope this is clear. Join in, Hemang. Yes, maybe you're a little bit late, but it's okay. Join in to this lovely session, marathon session, which is a big session for clearing all things related to standing waves, beats, and Doppler effect. Hi Manan, join in. All right, so let's start with some problems. Welcome all the new members out here to this family. Yes, let's start with this problem. 2016 question. Very important question. Let's see how many of you get this. There is a pipe which is open at both ends and has a fundamental frequency F in air. It has fundamental frequency F in air. The pipe is dipped in water vertically so that half of it is in water. The fundamental frequency of that air column now is how much? Let's see how many of you get this. If you are in 2016, will you be able to do this if you are in 2016? Come on. I hope all the studies are going on very well, Hemang. All right. Yes, Yashwant, why not? Physics is the same. Don't worry about it. Let's see how many of you can do this. Okay, I'm removing the options. Now let's see the visualization part. There was a pipe which was open at both ends and it has a fundamental frequency F. Fundamental frequency means, see, if this is open, there will be an anti-node here and there will be also another anti-node over here because it is open at both ends. Now the fundamental frequency will look something like this. The standing wave will be formed in this manner. Now think about it. When the pipe is half dipped in water, look at this, this is the pipe, it is half dipped in water. Won't this end behave like a closed end and this end behave like an open end? Isn't that true? Because this is a water surface, it's like closed end. So can I treat it like half the pipe where one end is open, other end is closed? So the open end will have anti-node, guys, and the closed end will have node. Don't you agree with this? Don't you agree? So now think about it. What is the fundamental frequency of this pipe? Antinode, node. So I think it will look like this. Now tell me, whose wavelength is more? Who has more wavelength? This one or this one? Believe me, both of them are same. Yes, both of them are same. Do you see that? Do you see that, guys? Both of them are actually the same. Yep. Very good. Because if you extend this further, this was only half the length, you will see a lobe over here. So if the lambda over here and lambda over here are same, don't you think the frequency here and the frequency here will be the same? So the answer is F only. Correcto. So that's the answer, guys. The answer is F. Believe me. Yes. This was asked in 2016 JEE question paper. And a lot of people thought length becomes half or something like that, and they wrote 2F or F by 2 and something like that. So a lot of people get it wrong. Okay, so the answer is B, which is F. Okay, so it is B, guys. So yes, this is B. B was F, D was 3F by 4. So be careful. Hello, Richu. Welcome. Join in. Join in. How to catch up, Hemang? Sorry, Deepak. You're still in rotation. Deepak, let's do one thing. So all the new timers out here, in case you have any query, don't worry. If you see any of my previous videos, whatever students post after the video in the comment section, whatever doubts they have, how to study, what to do, which book to use, can I do this, can I do this, can I not do this, anything that you have, post it below the video. I'll respond to you. That's option 1. Option 2, you can contact me on Instagram, Shreyas_Vedantu, SHREYAS_Vedantu. I'll respond to you within a day or 2. All right. So that's what we can do. Cool. Yes, Hemang, Deepak, and all the other new minions out here. All right. Let's get going to the next question. And here it is, 2019 question. This was asked in JEE 2019. There is a closed pipe and it has a fundamental frequency of 1.5 kilohertz. How many the overtones can be distinctly heard by a person with this organ pipe, assuming that the highest frequency a person can hear is 20,000 hertz? No problem, Dia. You can post it up as comment in the video. I'll definitely respond to that, Dia. Don't worry about that. Yes. Oh, okay, Deepak. Okay, fine. Yes. So let's see how many of you get this. This is also a very interesting question. Very important question, guys. Let's see how many of you can do this. Come on, guys. Think. First of all, what kind of pipe is this? Think about it. This is a closed organ pipe. Now, the meaning of a closed organ pipe in general means a pipe closed at one end. Remember this. Usually, you will not get pipe closed at both ends. You will have pipe closed only at one end. So closed pipe means this, and open pipe means open at both ends. Keep this in mind. Now when there is a pipe which is closed at one end, what frequencies will you get? The frequencies will be always odd multiples of the fundamental frequency. It will be always odd multiples of the fundamental frequency. Now think about it. What is the fundamental frequency? It is 1.5 kilohertz. Right? This is the fundamental frequency. So what is above this? 3 times of that. 3 times of that will be, think about it, 4.5. Next frequency, think about it. 4.5 ke baad, what will it be? 7.5. 5 times of 1.5. 7.5 kilohertz. Next, 7 times of that. That will be nothing but 10.5 kilohertz. I hope this is making sense. Next, take the next multiple, guys. Yes, 13.5 kilohertz. Next, after 13.5, 16.5 kilohertz. Correct? I hope this is clear, guys. Yeah, and the last one obviously 19.5 kilohertz, of course. So now count. This is the first overtone. This is the second overtone, third, fourth, 1, 2, 3, 4, 5, 6. So this is the 6th overtone. So how many overtones will you hear? 6 overtones. That's the answer. Correcto. Yes, that's the answer. Very good, Hema and others. Hi, Fafi. Oh my God, Yavar, both are best friends here. Don't make me choose like that. Okay, cool. Let's get going ahead with the next question. So that was the answer, option A, 6. Next question, 2019 question. There is a string which is clamped at both the ends and it is vibrating in its 4th harmonic. The equation of the wave is this, 0.3 sine 0.157x cos 200 something t. The length of the string, if all of them are in SI units, is 20 meters, 80 meters, 40 meters, 60 meters. Let's see how to do this question. I'll erase all the options. We need to get the correct answer. What is the length of the string? Let's see how to do this. Those of you who want to do it independently are free to do so. I'll be solving it right now. If you feel like you can do it on your own, continue. If you feel that you should listen to me, do that. Okay. Now, string is clamped at both ends. It is vibrating in its fourth harmonic. Let's visualize what is fourth harmonic. Fourth harmonic will be 4 loops. So 4 loops drawn like this. So 4 lobes I can say, or loops. Okay. And each lobe is lambda by 2. So the total length of the string will be 4 times of lambda by 2, which is nothing but 2 lambda. So the total length of the string is going to be 2 lambda. That's one thing I got. The only problem is I do not know the wavelength. Can I find the wavelength? Maybe yes. Look at this over here. This term, all right, you will see something is multiplied by x. What is this number? This number is nothing but k. Remember, it is always kx and omega t. So if you know k, you also can find the wavelength. So what is k? K is nothing but 2 pi by lambda. So 2 pi by lambda is 0.157. Now 0.157 can be written down as 1.57, and 1.57 by 10. Now 1.57, believe me, is nothing but pi by 2. Yes, it is nothing but pi by 2. So it is pi by 2 into 10. All right. So that is 0.157, and that is 2 pi by lambda again. Now pi by, and therefore lambda will be equal to 2 2s are 4 into 10, 40. So 40 meters. But that's not what I want. I want the length. So the total length will be 2 multiplied by 40, which is 80 meters. That's it. So guys, if you understand what is waves, what is standing waves, etc., believe me, the problems are very simple, very easy formula based questions. Albert, I'm very good. Yes. Cool. Let's get going ahead with the next question. So like you can see, 80 meters is the answer. Now, let's talk about another thing which is called as a sonometer. Now, this is a very simple experiment. What happens? And I'll tell you a cheat code over here. Listen to me. So there is a sonometer. And what is this sonometer? This sonometer is used to determine usually a frequency of an unknown tuning fork. Now, I know the last year has been horrible and probably you never went to school and never did practicals. But whenever you get to do this practical, this is how it is done. There is a box, it's called sonometer box. You have 2 small triangles which you can move, adjust, and those 2 wedges act like fixed ends. And there is a string which passes over a pulley, and there is a mass which is attached here. That mass will have its own weight, mg. So there will be some tension which will be created in the string. Now that tension can be used to calculate the wave speed on the string. So if you generate a wave, it will pass on the string. That wave speed will be root of tension by mu, and tension is nothing but mg divided by mu. So what you do is, the mass is given to you. Yes, the person who is in charge of the laboratory will give you that mass. You will measure it. G, you know the value, 9.8. Mu, the mass per unit length of the string. This is for the string, keep this in mind. That will be either given to you or you are asked to find out. You know the length of the string, you measure the mass, you will get the mass per unit length. Hello Sanjay, my god, Hemang, you are there from 2 accounts. And some of you have also done this as a practical, very good. Harshit, you can crack JEE even from Antarctica, let me tell you. You can crack it. Believe me, you guys are the luckiest generation who can sit at home and crack JEE. I used to travel 20 kilometers when I was your age to just attend a JEE coaching center because there were no good classes. And that was such a waste of time. If I could get all these facilities at home, and secondly, if somebody was there to solve my doubts online, I would not even bother to travel somewhere there. It was such a stupid thing. I feel I could have done much better. You guys are really lucky. Okay. Now, what you do is, next part, you take a tuning fork. You take a tuning fork and you are generally assigned lab partners. Okay, you are assigned lab partners. This tuning fork is something whose frequency you don't know. You take the tuning fork, you hit this tuning fork on your lab partner's head. Okay, so you have to hit this tuning fork on your lab partner's head. So the tuning fork will start vibrating. Now that vibrating tuning fork is placed on this box. Those vibrations will travel through this box, through this wedge on the string, and you will see the waves will start getting reflected over here, and you will see beautiful standing waves over here. You will see beautiful standing waves here. You know the length between them. You ask your lab partner whose head is vibrating, and he will measure the number of loops over here, and then from this you will write N and V, you know, divided by 2L. L you can measure, V using this, N you ask your lab partner whose head is vibrating, and that will give the frequency of that unknown tuning fork. I hope this is clear. Sanjay, I can post, just post all your doubts in the comment section below. I'll definitely respond just like I do for all the other doubts which other students ask. Right now, since we are continuing with the section, I would prefer to maintain that flow. All right, cool. That is what a sonometer experiment is. But I'll tell you what the cheat code is. You know what happens? On the tuning fork, the number is written, and that number is actually the frequency of the tuning fork. Yes, the frequency of the tuning fork is actually mentioned. Smart lab attendants, they erase that number. But not so smart lab attendants, they leave that number on the tuning fork. So what we used to do, we already know that number. F we know. N, I will ask my lab partner, what is your lucky number today? He will be like 5. I'm like, okay, fine. I'll put N as 5. V, very easy to calculate using this formula. All right. I know V, I know N, that is the lucky number that day. F, that's given. I'll get the length. I will adjust the length accordingly, and I will do the practical in 2 minutes. But just to make sure that the lab attendant does not get doubt on me, so I'll just make sure that the length is not exact. I will change the length little bit, and if the frequency of the tuning fork example was written to be 440 Hertz, we'll give the final answer as 435 Hertz, so that it's not doubtful. Yeah, that's what is done. Yes, cool. Let's get going to the next one. End correction. End correction. Let's see this. What is end correction? So, oops. Yeah, 1 second. In a pipe which is open, usually you should get the antinode exactly at the open end, but you never get the antinode exactly at the open end. It is slightly outside, because of which you might get a small error in the calculation. Very good, Yalini. All the minions have noted it. In what situation, Pranav? To find out the unknown frequency of a tuning fork, Pranav. I hope that makes sense. Okay. So the antinode is slightly outside. So to account for that, understand, if this is the geometrical length, this is the geometrical length, the actual length, which is effective, is slightly more. This is the effective length, and you can see that the effective length is, let's say the geometrical length was L0, the effective length is L, then L is actually, L is actually L0 plus some end correction. This E is called as end correction because you have to account for that. The antinode is slightly outside, that's what is practically found, and this value of E is always 0.3 times the diameter. Keep this in mind. The diameter of this pipe, so 0.3 times of that, that is the value. Keep this in mind. I hope all of you have noted this. Keep this in mind. Now there are some problems based on this. Let's start doing the problems. And before that, the next experiment, which is also important. Alright, because questions come on this. Questions do come on this, and that's why I'm giving you this. Resonance tube experiment. I'm not sure how many of you have done this in your school or colleges because of the lockdown, but this is also a very funny experiment. So you again have a pipe which is dipped in water. Alright, the pipe is dipped in water. Now there is a stand, and you can clamp that pipe, you can release that pipe, and you can move that pipe up or down. First, the pipe is completely immersed inside water, almost. Now you take a tuning fork. Okay, you take a tuning fork. Again, this has to be done with your partner. The partner is very important. You take the tuning fork, hit it on your lab partner's head. The tuning fork will start vibrating. Now place the tuning fork over here. You will see the sound will travel below. It will get reflected from the water surface. And because there are two waves going in opposite direction, you will see a standing wave over here. Alright, so you will see a standing wave over here. Now, what is important is you keep adjusting the length till, again you ask your lab partner, come on, place your ear over there, till you hear a loud sound. When you hear a loud sound, that's when you will see resonance happening and you will see standing wave formed. Yes, so you will see standing wave formed over there. Understand that. So you note down the length and that's it. You know the formula for frequency, guys. So you know the formula for frequency. F is odd. Why odd? Because this is open closed. Keep in mind, this is open, this is closed end. So odd times V by 4L. Now what is this setup used for? This time you know the frequency of the fork. F is known. Odd number is 1 because you keep moving the pipe up till you first hear that sound. So this is the first harmonic you get. V is not known. L is known. Only thing unknown is V. So you can find the speed of sound using this setup. Yes. Yes, there will be standing wave inside the tube. Correct, Pranav? Yes. Yes, that's how it will be. So everything is known and that's how it will look. So this is how it looks like. So this is the first harmonic. Actually, the standing waves are produced like this. There is a node here because this is a closed surface and this is an open surface. The first harmonic, when it is formed, it will be like this. So you keep pulling up that pipe up till the first time you get a loud sound. When you get the loud sound, that means antinode is formed here, node is formed here. Now, if you still want to do this experiment again, you can keep pulling this pipe up. As you pull this pipe up, basically the water level will go down. The next time you will get the third harmonic is when the water level comes down till here. Alright, so when the water level comes down till here, you can see again a node will be formed. That time the length will be 3 lambda by 4. I hope this makes sense. Is it making sense, guys? So first time you get loud sound is lambda by 4. Next time you get it is when it is 3 lambda by 4. And next time you will get it when it is 5 lambda by 4. That's how it works. So here n is 1. Next time n is 3. Next time that odd number is 5. Keep this in mind. Okay, cool. Good evening, Vishala. G Vishala, join in to our lovely family, and all the new members, do not forget to hit the subscribe button. It is for free of cost. And do not forget to hit the like button because that is also free of cost. Show your love and support. Alright, cool. Yes, yes. Let's do this 2018 question. Come on, guys. Hello, Nike. Abhilasha Reddy. Abhilasha Reddy. Oh my God. Welcome, welcome. Such a long name. Sounds like a nice paragraph. Alright, join in. Okay. How about this question? 2018 question. The end correction of a tube is 1 centimeter. If the first resonating length is 10 centimeter, what is the next resonating length? Think about it. Chetna, actually the standing waves will be formed even below water, but that is not so important. Remember, wherever that surface is there, that behaves like a closed end. Although that resonance will continue, that standing wave will continue even below that. Don't worry about it. Yes. Hi Deepak, welcome. Alright, so let's see how to do this. Now, end correction is 1 centimeter already given. Tuning fork is resonating with that length and the length is 10 centimeter. What it means is, guys, the geometrical length is 10 centimeter, but since you have to also account for the end correction, because remember the standing wave is formed exactly like this. So the antinode is slightly outside. So this 10 plus 1 centimeter is actually the value of lambda by 4. Remember, this is lambda by 4, guys. I hope you remember that. I just told you, fixed, free end, closed, open. This is node, antinode. Distance between node and antinode, lambda by 4. Because one lobe is lambda by 2. So half of that, lambda by 2 is half, lambda by 4. So guys, lambda will be equal to 4 into 11, which is 44 centimeters. Okay, I don't think I need it, but I'll just do one thing. I'll just put value of lambda by 4 is 11 karke. Okay, I'll just put it over here. Now, what is happening next time? The next frequency, next frequency will be for a larger length, but it will look something like this, guys. Oops, 1 second. It will look something like this, I believe. And what will be the length? I don't know, but that length plus that end correction. How much is the end correction? 1 centimeter. That should be how many times lambda by 4, guys? I believe it should be 3 times lambda by 4. Do you agree with this? Lambda by 4, lambda by 4, lambda by 4. Do you see that? Hi Vignesh. All right. Do you see this? Lambda by 4, lambda by 4, lambda by 4. So 3 lambda by 4, that's the next resonance length. So guys, that means L will be equal to, what is 3 lambda by 4? 3 into 11. So 3 into 11 and take that 1 on the other side. 11 3s are 33, 33 minus 1, 32 centimeters. That is the answer. If somebody can visualize this simple thing, that's it. He will give the answer within 30 seconds. Okay, cool. Very good, Priyanka, Princey, amazing. Very good, Nike. Very good. Hello, Vignesh. Yes, very good. Very good, Yavar. All right, let's get going. 32 centimeters. Next question coming up on your screen. In a resonance tube, this was again asked in 2020. Yes, very recent. When the tube is completely filled with water till a height of 17 centimeters from the bottom. Very interesting. They have not given the space of air. They are given the space of water. Very tricky. It resonates with a fork. When the water level increases, then the same fork, then the height of water is 24.5 centimeters. What is the frequency of the tuning fork if the speed of sound is 330? Check this out. Very, very interesting question. Options are given. Don't worry about the options. Let's solve this. Let's try to visualize this first. Okay, let's try to visualize this. First of all right, so there is, okay. Now, there is a pipe. First time the water is filled till a height of 17 centimeters. So water is filled only till here, and this height is given to be 17 centimeters. Next time the water is filled till a larger height, so maybe here or something, okay, and that height is given to be how much? It's given to be 24.5 centimeters. Now remember one thing, I have told you this, okay, if I have to show the standing waves, how will it look like? Let me show approximately how will it look like. Open end will have antinode, keep this in mind. This acts like a closed end, so there will be a node here. Now the same thing should continue, alright? And because this was the next immediate resonance, think about it, I just draw it, okay, like this. There will be exactly one more lobe over here. I hope you realize that. Exactly one more lobe, because this was the next immediate resonance. So at 17 centimeters and at 24.5 centimeters when water was filled, you got the two successive resonances. You heard two loud sounds. The tuning fork resonated with this this column. So guys, think about it. Manoj, whenever that will happen, I will definitely let you know. Don't worry about it. First, concentrate now. Guys, now think about it. How much is this length exactly equal to? Isn't this length, actually speaking, think about it, the length of a lobe? And what is the length of a lobe, extra lobe? Guys, isn't it lambda by 2? So guys, Haven't you realized now lambda by 2 is actually this length minus this length? So isn't it 24.5 minus 17? Look at this, guys. I hope this makes sense. So 24.5 minus 17, guys. Check it out. What will it be? What will it be? Yes, won't it be 7.5 centimeters? So won't lambda be 15 centimeters or 0.15 meters? Now our job is done. F into lambda is V. Therefore, F is velocity. What is the velocity? 330 divided by lambda, which is 0.15. How much will this come out to be? Yes, 15 into 2, 30, that means 315, 330. So 22 times, and then you will have 2 more zeros. Check it out. 22 and 2 more zeros, that many hertz. 2200 hertz. I hope this is clear. I hope this is clear. Yes. Is this understood, guys? Such a beautiful question that was asked in 2020 in JEE. Yes, Nike, please ask, please ask, please ask. Very good. Deepak, don't worry how many questions are asked, because nobody can tell. If some teacher is telling you 5 questions are asked, then probably they are lying. Remember, no teacher can tell how many questions will be asked, because it's up to the examiner and the computer how many questions will be asked. But you can create a general trend, at least 1 question approximately will be asked. Why one lobe is formed? Well, I'm believing that love is lobe. Okay, so one lobe is formed because, see, the first resonance happens at 17 centimeters. The next resonance happens at this 25 centimeters. So remember, there must be always a node here. So that means when the water is filled, all right, it should reach the next node to get the successive resonance. So that's why the increase in the height must correspond to one lobe. Yes, I hope that's clear. I hope this is clear. Yeah? I hope, Nike, that's fine. Let's get going. Okay. So let's get going to the next question, 2200 hertz. Let's come to beats, guys. Oh my God, so many things to be done today. I hope, guys, you guys have that stamina now. Yeah, don't worry. I'm going to complete this thing today because it's very important. Subhash, don't believe we are like that randomly. Always there is a question on Doppler effect. There have been instances where there were no questions on Doppler effect. So guys, please understand, this is not board examination. In boards, there is a definite pattern. 5 marks for this chapter, 3 marks for this chapter, 10 marks for this chapter. Tell me, does JEE officially release in the brochure that these many questions will come from this chapter or these many marks from this chapter? No, right? So whenever I have also conducted some sessions, you know what I have done? I have always told you this is the general trend what we have found using or seeing many past year papers. But that is not sure. They might decide that they will not even ask one single question from Waves, or they might decide that this time we are going to ask 3 questions from Waves. So nobody can tell that. That's the problem. So don't think that there will always be a question or there will never be a question or there will be 3 questions. No. Always try to learn all the topics. Don't know which topic might come, which topic might not come. It's completely your luck, let me tell you. Yeah, cool. Let's get going. Now, what are beats? Now, trust me, guys, many of you do not know beats. You might tell, sir, we have studied beats. But no, most of you do not know what exactly beats is. And today, I'll make you realize what exactly beats are. Are you guys ready? Well, when you have 2 sounds, that's what the definition says. When you have 2 sounds very similar to each other, that's when beats are produced. And when beats are produced, so when you have 2 similar sounds, let me write it down, similar sounds, that is frequencies are close, what you will get? You will get loud sound and faint sound. You will get loud sound and faint sound. That phenomena is called as beats. Now let's try and understand this. If there are two sounds, frequency F1 and F2, if they are sounded together, you will get beats. Now this is very, very interesting. Let's see a small demo on this. Let me get back my graphs out here. Okay. Yes, I do live in Bangalore. I do live in Bangalore. All right. Now, how about creating y is equal to 2 sine maybe 1.6x. This is the graph. You can see that. All right. This is the graph which you can see. Now, let me create another wave. Okay. But this will be y is equal to 2 sine 1. Maybe let's say 7x. Example. You will see that now, Subhash. Hold on. Now, do you see any difference between this wave or this wave? Like that. Look at that. Do you see any difference as such? They look very similar because the numbers are also very close by. Alright. But let's do a small trick. Magical trick. Let's place them, both of them together. Now you can see there is a small difference between the waves. A small difference between the waves. Now, look at them. Their crests are together initially, but as you go forward, their alignment is broken, and you can see slowly after some time, somewhere maybe over here, all right, somewhere over here maybe, you can see the crest and the trough are coming together. So don't you see destructive interference? Yes, destructive interference out here, because their multiplying factor is not the same. One is 1.6x, one is 1.7x. So their wavelengths are different. Do you understand that? Their wavelengths are different. That's why there is destructive. And again, after some more time, do you see constructive? And again, after some more time, do you see destructive? So guys, I hope you see that these waves, all right, these waves align themselves and get destructively interfered after some time, and this keeps on happening successively. Now, what happens when I add both of them? Let's see what happens when I add both of them. Okay, so here we go. I'll just zoom on to that. But just to make sure that things are very clear, so let's make it maybe 4x and maybe 4.1x maybe. Okay, and instead of 2, maybe we can have 3. And also over here maybe 3. Okay, so now also you can see that, guys, the waves are aligned and not aligned as you go forward, and again they get aligned somewhere else. You can see that happening. Okay, now you can create more difference between those two waves, and you will see that will happen more frequently or less frequently. Like for example 4.3. If I make it 4.3, see the difference between them is large. So you will see right now they are aligned. Now they will go out of phase. Again they will become aligned. Again they will go out of phase, but that will happen very fast because the difference between them is large. So they will keep on increasing their difference really fast. Now let's add both of them. Let's add both of them and see what exactly happens. So this is y1 and let's say this is y2, and are you guys now ready to see y is equal to y1 plus y2? Let's do this. y1 plus. Get ready for this, guys. This is going to blow your minds now. Let's see this. y1 plus y2, and there we go. And let's remove the other graphs. Beautiful graph. Look at that. Loud sound, constructive interference, destructive interference, constructive interference, destructive interference. The sound becomes big, small, big, small. So that's what happens when you add these two. This is beats mathematically. No, Riya, I'm not from Tamil Nadu, but I was born in Tamil Nadu. All right. Okay. Cool. I hope after this you will never forget beats mathematically. Cool. That's what my job was. So that was the demo. So this is beats. Now let's see some few things out here. Over here I can say constructive interference, and I can say loud sound over here, and over here I can say destructive interference, and I can say faint or no sound. All right, and from one loud sound to next loud sound, that is called as the beat period. The beat period is from one loud sound to next loud sound, or from one low sound or faint sound to the next faint sound, one and the same thing. Then there is something called as beat frequency. The beat frequency is obviously 1 upon the beat period. What is the beat period? Beat period is from one loud to next loud. How frequently do you hear those loud sounds? That delta F has a formula modulus F1 minus F2. So whatever are the two sounds, just take the positive difference. That's why the modulus. So that is the beat frequency. I hope this is clear. Kathi, first of all, let me tell you, you are not the only one who is nervous. There are thousands of students like that, but there have been situations where students have performed exceptionally well just because they have followed certain rules in the last few weeks. Believe me, don't worry. The main thing is, I'm not saying you should become All India rank 1 or All India rank 100. Even if you are going to get a seat in NIT or any other good top college, I would be really happy. So for doing that, you have to follow certain rules. I'll tell you what those rules are. Either you ping me on Instagram, all right? Because I have already been sharing all these things with other students. So I'll just tell you whatever things have to be done in a just small manner. So either you ping me on Instagram, Shreyas_Vedantu, or leave a comment below. I'll definitely help you out. Okay? Yavar and all those other students out here. Let's get going to the next question now on beats. Let's do this. Let's do this. Thank you, Yashwant. Cool. Let's see. Okay. How many of you get this? 2002 question. A tuning fork arrangement produces 4 beats with another tuning fork of 288 hertz. Okay. When some wax is placed on one tuning fork, then it produces 2 beats. What is the frequency of the unknown tuning fork? Guys, these kind of questions are very common. Now let's see how to do this. See, there are 2 tuning forks. Fork 1 and fork number 2. Okay. Now, notice what is given. There is one tuning fork which is having 288 cycles per second, or basically 288 hertz. How many beats it is producing? 4 beats. What was the beat formula? Bigger frequency minus smaller frequency. Do you know the tuning fork frequency of this guy? No, you do not know that. So do you know who is bigger? No, right? Because you just know the difference is 4, because that's the beat frequency. So the other fork's frequency could be either 288 plus 4. So what is 288 plus 4, guys? It is 292. Or second option is, it could be 288 minus 4, which is 284 hertz. Now the problem is, I do not know which one to choose. For that, they have given another piece of information. When some wax is added on the unknown tuning fork, it produces 2 beats per second. On this fork, if you put some wax, what happens when you add some wax? The frequency reduces. Why? Because it becomes heavy, and because it becomes heavy, it will oscillate slowly. That's why the frequency will go down. So guys, think about it. If, for example, the frequency was 292 hertz, what is the difference between them? 4. If you add some wax, maybe that 292 might become 290. What will the difference become? Exactly 2 hertz, and that is what is given. So yes, 292 hertz should be the correct answer. But if you choose 284 to be your answer, for example, suppose if that frequency goes down, let's say to 282 hertz, then what will their difference become? Their difference will become 6 hertz. But that is not the beat frequency. The beat frequency is 2 hertz. So hence, this will not be the answer. I hope that makes sense why it should be 292. Correct. I hope this is clear. I hope this is clear, minions. Okay. So this is how you solve the problems. This is how you solve the problems. And that's the answer. Cool. Now, there is one more question which I feel you should do it as homework. So try this out. I'll give you as homework, guys. Try this out. This is very similar. Same thing. There was a tuning fork of frequency 256 hertz. It makes 5 beats. With the second one, all right. And later on, when you change the tension, of that string, it produces 2 beats. So think about it. For a string which is fixed at both ends, what happens when you change the tension? I'll just give you a hint. The frequency formula was NV by 2L, and that V is root of tension by mu. Use this, you will get the answer. All this. Use this formula, you will get the answer. This is very important problem. 2003 question. Very interesting question. Try this out. And you can see the answers are even more simpler. They have given 256 minus 2 plus 2 minus 5 plus 5. So think about it, which of them will be correct. I have pasted the answer in the next slide. Shall we go to the last part, which is Doppler effect? I hope you guys are ready because I'm going to need more 20 minutes. Yes, I'm going to need more 20 minutes to complete Doppler effect. But trust me, put in your full energy, put in your full josh the next 20 minutes. And believe me, after this lecture, if a question comes on Doppler effect, you will be able to do it. Come on, refresh yourself, re-energize yourself, because we are going to do Doppler effect together. Let's do this, all the minions, let's do that. So, if a Pandu is standing beside a railway track and there is a train, Shatabdi Express or Rajdhani Express going, and the train is continuously honking, all right, or there is a siren which is going by. So, Pandu will hear the sound differently when the train approaches, and he will hear the sound differently when the train is moving away from him. And he will hear it completely differently when the train is stationary. And I'm pretty sure all of you would have heard you would have had very similar experiences when a train is standing and when it is honking, and when the train is moving, the horn sounds very different. So what is it that is happening? Let's look at that. That is called as Doppler effect. So when a source moves, or when the observer moves with respect to the source, you will see the wavefronts that are produced are slightly in different manner. So guys, usually what happens, a source which is stationary will emit wavefronts in all the directions. These wavefronts will pass by the source, pass by you. Now, whatever is the rate at which these wavefronts are emitted from the source, that's the exact rate at which the wavefronts will pass by you if both of you are at rest. But the moment you start moving or the source starts moving, this is how it's going to look like. So if the source moves, understand the older wavefronts will be emitted behind, the newer wavefronts will be emitted from wherever the source is. See, these are the newer wavefronts. And do you notice one thing? If you are an observer here, you will see the gap between the wavefronts has reduced. You will see the gap between the wavefronts has reduced. But if you are an observer here, then because the spacing between the wavefronts has increased, you will see the distance between them has increased, so the wavelength will be larger. So that's why, guys, understand, if you are in front or behind of that moving source, you will see the wavelength is different, and you will see also the frequency of sound is different. So if you are in the front, what will you hear? Will you hear more frequency or less frequency? Yes, think about it. Yes, Princey, I will show the same one. Yes, correcto. So guys, think about it. Will the frequency be more for the case of a front observer? Yes, it will be more. Very good, Aishwarya. And if you are behind, then what will be the frequency? The frequency will be less because the source is going away from you. That's the whole idea. Now let's see what is the Doppler effect formula, and after this you will never have that confusion. Let's see. So if you have a source which is emitting some sound of frequency f0, and if you have a detector, this is nothing but a source and this is nothing but a detector or an observer, okay, and let's say c is the speed of sound, let's say c is the speed of sound, okay, and vs is the speed of the source, and let's say vd is the speed of detector, okay, the speed of detector. Then the apparent frequency means the frequency which is heard by the detector. That frequency is, first of all, f0 into a fraction. Fraction means just like 1 by 2, 3 by 4, etc. fraction. Now, if think about it, if you are going to hear more frequency, then this fraction will be more than 1, and if you are going to hear less frequency, this fraction will be less than 1. And remember, whenever fractions are more than 1, numerator is more than denominator, and whenever fractions are less than 1, then the denominator is more than the numerator. Now think about it. Okay, try to recollect the formula that is there in your mind. See, this is how I remember the formula. Always put C above and below. Always put C above and below. That's how it is. And which alphabet comes first amongst S and D? Which alphabet comes first? S or D? D. So put D here, S here, and put V. That's it. VD and VS. So there is no confusion right now. Yes, Avinash, this is going to be there for JEE 2021. Yeah, 11th and 12th, both portions are there. And then just put plus or minus. That's it. This is your formula. You should not get confused after this. Now the only thing remains is the sign convention. How to put this plus or minus, don't worry about it. I'm going to tell you. That's how you remember the formula first of all. Cool? Now, how to remember the formula? How to remember the sign convention. Let's see that. Let me take few cases. Source is going here, detector is at rest. Source is going here, detector is at rest. Source is at rest, detector is moving away. Source is at rest, detector coming here. Okay, then source is going here, detector is also going here. Source is going here, detector is also going here, and then maybe source is going here, detector is going here, and lastly source is going here, detector is going here. I hope you realize all the cases are put up here, over here, all the cases. So now let's see how the formula comes. See guys, that frequency heard by the detector will be f0. Remember C on the top, C below? C on the top, C below? That's it. Now listen to me carefully. Is the detector moving? No. Where does the detector come? On the top. So there is nothing on the top. Who is moving? Source. Where does source come? Below. So just put Vs. Okay, I hope this is clear. Similarly over here, this F will be F0, C, C. Source is moving, so only Vs will come. Detector is not moving. In this case, F will be equal to F0, C, C. Detector is moving, so only Vd will come. Here, F is equal to F0, C, C. Only detector is moving, so only Vd will come. I hope this is clear. I hope this is clear, guys. Cool? Cool. F0 is not the frequency of the detector. F0 is the frequency of the source, Aishwarya. Actual frequency. F is the frequency which will be heard. I hope that's fine. Okay? Okay. Now, how about those signs? Let's talk about those signs. What will be the sign? Now, see guys, think about it. If a source is coming towards you, you are the detector, source is coming towards you, will frequency be more or frequency be less? Will frequency be more or will frequency be less? It will be more. If it is more, then what should happen to this fraction? It should increase, right? So denominator should be smaller, right? Denominator should be smaller. So make it minus. This has become smaller. That's it. Similarly, if the source is going away, you're going to hear less frequency. If you're going to hear less frequency, shouldn't this fraction be less than 1? If it has to be less than 1, this fraction, shouldn't the denominator be more? So you will put a plus sign. That's it. Similarly, look at this. Source is at rest. You only are moving away. Still the frequency will reduce. Source is at rest. You are moving away. Won't the frequency reduce? So guys, think about it. Shouldn't this fraction be less than 1? Shouldn't the fraction be less than 1? So think about it. Numerator should be less. So it is minus. So it is minus. Alright. So numerator will decrease. Try to adjust it accordingly. Here also, is the detector moving towards the source? Yes. If detector is coming close, more frequency, this fraction should be more than 1. If it is more than 1, make the numerator bigger. That's it. That's it. Correcto. Understood? Let's do this one last time here. F is F0. F is F0. C, C. Here both are moving. So I'll put VD, VS. Again, same thing, guys. Okay. VD, VS. Alright. So I'm not going to write the entire thing. Just think about it. Alright. Let me actually write it down. No problem. Okay. C, 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 VD, VS. Here, treat each one of them independently. Treat each one of them independently. Is source coming towards the detector? Yes. If source comes towards, what should it do? The frequency should increase. How can you increase the frequency? By making the denominator smaller. Make this smaller so that the frequency increases. So minus sign. Correct. And what will you do over here? Detector. See what detector is doing. Detector is going away. So frequency should reduce. How will you reduce the frequency? By making this numerator smaller. That's it. I hope this is clear. Similarly, think over here, the source is going away. So frequency should reduce. Denominator should, frequency should reduce. Denominator should increase. Detector is going towards. If detector is going towards, frequency should increase. If frequency should increase, think about it. It should become plus. That's it. I hope this makes sense now. Yes, correcto. And similarly, over here, source is going away. Source is going away. Frequency should reduce. So this should become plus. Detector is going away. So frequency should reduce. So minus. That's it. Here, source is moving towards. So frequency should increase. This should become smaller. So minus. Detector is going towards. Frequency should increase. So make this numerator plus. That's it. Yes, Dastagir Mullah, why not? Who has told you you will not clear? If somebody has told you, please tell me his name. Alright, you can definitely clear. That's enough time. Okay, so let's do some problems, guys. Here is, so 4 questions more. That's it. No problem, Princey. 4 questions now. 4 questions and that's it. I know some of you have also 9 o'clock classes somewhere else, but 4 questions. Let's do this. Yashwant, I'm actually from Pune, but right now in Bangalore, but I have done my graduation from Nagpur. I was born in Tamil Nadu and have stayed in many places. I have also stayed in Bombay, IIT Bombay. Also, I have done my research projects. So, I've stayed in a lot of places. Okay. So, now, here it comes. This train is moving. Look at that. Look at that. Okay. The train is moving. The question is, what is the frequency heard? So let's write down all the relevant information. Okay, speed of the train is 30 meters per second. This is 30 meters per second. This is the detector at rest. Okay, so let's see what is our formula. F is, I am not interested in the final answer. Let me tell you that. I'm just interested in the plus minus numerator denominator, nothing else. Because calculation part, you can do it. So let's get it quickly. So person is moving. The train is moving. And all right, so our formula will be F0. What is F0? 1000. That is given, guys. 1000 hertz. And speed of sound, what is speed of sound? 330. Okay. Next, who is moving? Source. Where does source come? Below. So that means here. Detector is at rest, so nothing over there. Since the source is going towards the detector, what should happen? Frequency will be more. How do you make more frequency? By reducing the denominator, so minus. That's the answer. Dastagir, let me tell you, beta, even I never studied for NTSC, even I never studied for any other competitive exams before 10th, and still, you know, I cracked IIT, I got rank, all India rank. I also cleared the first round of National Science Physics Olympiad. Okay, and also guys, remember one more thing, that many of my batchmates who never prepared anything before that also cleared for IIT. Some of them even got 2-digit ranks and so many other things. So there is, if somebody has told you you cannot do that, they are wrong. You can still do it, beta. You are never late. Because agar karna hota, then maybe you will say that, sir, should I start preparing for JEE from 5th standard? No, obviously not. Okay, so don't worry. Baipu Reddy, I have already done AC currents. Previously, last week, I have completed AC. So please check out in the past videos of this channel. You will see AC currents has been done already. Don't worry. Okay, so that's the answer. Let's get going to the next one. The car is also moving now. The car is also moving. Let's see how many of you get this. The train is moving with 30. The car is moving with 20. So guys, the frequency heard will be 1000. All right, 330. Okay, source is the train, 30 here. Detector is the car, so 20 here. Decide what is the sign, guys, quickly. Decide what is the sign. Plus, minus, 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 plus, plus, plus. What will it be? No problem, Princey, no problem. Avinash, Tamil, Terilya. Okay, let's get going. What will be the signs? Think about it. They are moving towards each other. Source is moving towards, frequency should increase. Oh, denominator is minus. I hope that's clear. Next up, source is, the detector is also moving towards, frequency should increase. So plus, that's it. That's it. That is the answer. Correcto. So some of you got it, some of you didn't get it. Plus and minus, source is going towards, so it will increase. So new denominator should decrease to make it big. I hope you get it. Cool. Let's get going. Next, there is wind also blowing, wind case. Yes, wind is blowing. Then what to do? Let's see what to do. This is moving with 30. This is moving with 20. Wind is blowing with a speed of 10. Now what to do? Again, F is 1000 and you have 330. Source on the bottom, matlab 30 below, and detector on the top. And assign the signs as it is. Remember, since the source is moving towards, this denominator should decrease, so minus sign. And since the detector is also moving towards, the frequency should increase, so numerator will increase. Okay, cool. Now, how do you account for the speed of the wind? Guys, the only change that will happen is, because, think about it, the sound is going to travel from the train to the car. Because the wind is also moving, what will happen? Speed of sound will increase. That's it. That's the only change. The wind is also blowing in the direction of the sound, so it will only affect the speed of sound. So you just add plus 10 here and plus 10 here. That's it. Everything else remains the same. I hope this is clear. This is the new speed of sound. New speed of sound because the wind is also blowing. That's it. Understood? Avinash, I have made definitely I have made videos on pulley system. Please watch the playlist beta on the home page. There is a special playlist for Newton's laws and friction. In that I have made special videos for pulleys, multiple pulleys, how to calculate tension, and what are the shortcut tricks for multiple pulley systems, and opening up method to solve the problem in 5 to 10 seconds. I have made those videos. Please watch it beta. Okay, cool. So I hope after this you will never face any problem. Last problem for today. Okay, so here it comes. Yes. If train is moving and there is a big mountain or a reflecting wall, then the sound which comes from the train falls on that reflecting surface, and then it gets reflected back and it is again heard by the driver. The question is, what is the frequency of sound heard by the driver? Let's see how to do this. Pay attention. When the sound is emitted from the train, it falls on the mountain. Whatever frequency falls on the mountain will be reflected back. Whatever frequency falls on the mountain will be reflected back. So what is the sound frequency falling on the mountain? So let's calculate that first. Frequency on the mountain or the reflecting surface. Treat it like a detector. Treat it like a detector at rest, and this is basically a moving source. That's it. This is a moving source like this with a speed of how much? 30 meters per second. That's it. Now you'll be able to solve the problem. What is the original frequency? 1000. Detector is at rest. Acha, before that 330 here, 330 here. Okay. Detector is at rest. Nothing will come on the top, only the bottom. 30 will come. And since source is going towards the detector, frequency will increase, denominator will decrease to make it big, so it will become minus. So it will become, yeah, this much value. Okay. Now I'll just write it as 1000 multiplied by 33 divided by 30. Keep this in mind. Next up, whatever frequency falls on the mountain will be reflected back. Now the mountain will behave like a source at rest, yes, and the driver in the train will behave like a moving detector with a speed of 30 meters per second. So that frequency heard by the driver will be, think about it, will be the same frequency which was on the mountain. Whatever frequency was there on the mountain will be actually the frequency of that source, because the mountain will now behave like the source, into, again you will have 330 divided by 330. Okay, 330 divided by 330. Now think about it. On the top you should have detector is 30, source is at rest, so nothing over there. Detector is moving towards the source, so it should increase, so that's why plus. That's it. Now this value you take it from here, which is nothing but 1000 multiplied by 33 divided by 30, and this value obviously is 36 divided by 33. 33 will cancel and you will get this answer. Yes, I hope this is clear now. Everybody understanding this? Yeah, so this will become 1200 Hertz, correct too. Cool. So this is how you solve the problems on reflection of sound. Very important. Now one last thing that I would like to tell you, 2D Doppler effect, simple thing. Remember one thing, if source and detector are not moving along the same line, what if source is moving here and detector is, let's say, I don't know, detector is, let's say, moving like this, then what you need to do is just draw a line from the source and the detector and just take the components. Just take the components along that line. That's it. If this is Vs and this is Vd, then just take the components along that line. So what are the components? This will be Vs cos alpha and this will be Vd cos beta. Now forget everything else, just worry about the components along the line and then find the apparent frequency. It will be actual frequency into speed of sound, and then this detector speed, which is Vd cos beta, and source speed, which is Vs cos alpha, and since both of them are moving towards each other, plus minus. That's it. Yes, Nike, definitely. That's why I'm making these marathon series. And by the way, there are many lecture series even in Waves. I started on Monday with transverse and longitudinal, yesterday with electromagnetic, today with beats and standing waves and Doppler effect. So these lectures together will definitely help you. Cool? Understood, guys? How to do 2D Doppler effect problems? Okay, so that's it for today. Take this up as homework problem for 2D Doppler effect, all right? And do all this as homework. I've kept up the solutions as well as the answers in the slides, as well as in the Telegram group. You'll find the link. And do not forget to check out the crash course details in the description box below, where today onwards you are getting an additional 10% discount. So usual discount was 20%. Now you are getting more 10% discount using this coupon code SHCC. So limited time offer. The batch starts every Monday. Do not hesitate to join in. Do not forget to like the video and subscribe to the channel if you have not done it yet. Bye bye and take care, and see you tomorrow at 7 o'clock and 10 o'clock. 2 lectures tomorrow, 7 and 10. Bye bye. Take care. Glad, Avinash. Thank you very much. Thank you. Thank you very much.